In the 11th standard, we have seen about the circular motion. Now for 12th science, the first chapter, the name of the first chapter is the rotational motion. In the circular motion, that is the motion of the particle along the circumference of the circle. For the circular motion, there is a need of the centripetal force or the centripetal acceleration. The examples of the circular motion, that is the motion of the stone in the sling, or the motion of the tip of the minute hand, or the tip of the second hand. Now in the circular motion, the centripetal force or the centripetal acceleration, the centripetal acceleration is given as v square upon r, or this is taken as equal to r omega square. From this, the required centripetal force is equal to mass into acceleration. Therefore, the centripetal force F is equal to mv square upon r, or mr omega square. Now, these terms are again we are going to repeat in this chapter for the rotational motion. Now, for the rotational motion, we are going to consider about the friction also. We have seen about the coefficient of the static friction, kinetic friction, and the rolling friction. The static friction is greater than the kinetic, which is greater than the rolling friction. Now the static friction, the coefficient of the static friction Bs is equal to Fs upon N, where Fs is called as the force of limiting force of static friction, N is called as the normal reaction, which is taken as the weight of the body. Now these are the formulas which we are going to use in this chapter. Now the rotational motion. The rotational motion, that is the wheel of our vehicle, or the motion of the fan, that is the rotational motion. The different particles of the body perform the circular motion, and the centers of all of these circles lie in a straight line, which is called as the axis of rotation. Now the axis of rotation is term is important in the case of this rotational motion. If we take the example of our wheel of the bicycle or the wheel of our motorcycle, the axis of rotation is at the center of the wheel. In the case of the fan, the axis of rotation is at its center. Now for the rotational motion and the translational motion. In the case of the translational motion, there were different terms. They are taken as the displacement, which is taken as S. The velocity is taken as v. Now in the case of the rotational motion of the circular motion, the displacement is called as the angular displacement. Angular displacement is taken as the theta. The angular displacement is measured in the radian. Then the velocity in the rotational motion is called as the angular velocity, which is taken as the omega. Theta is measured in radian. The omega is measured in radian per second. That is the angular velocity. Now after that, the acceleration. In the case of the translational motion, we call the acceleration. In the case of the rotational motion, we call the angular acceleration. The angular acceleration is defined as the rate of change of the angular velocity. That is alpha is equal to d omega by dt. That can be also taken as omega 2 minus omega 1 upon t. The unit of the radial acceleration, angular acceleration, is radian per second square. After that, the term is called as the force. Force is equal to mass into acceleration. Force is equal to mass into acceleration. For the rotational motion, the term is called as the torque. The torque T is taken as equal to I alpha. Torque T is equal to I alpha. This torque T can also be taken as F into R, F into R. Now these are the vector quantities that can be explained in the vector form afterwards. That is the torque in the rotational motion. Whenever there is a rotational motion, we will take the term as a theta, omega, alpha and the torque. In the case of the translational motion, we will take the term mass m. For the mass m, there is a term in the rotational motion is called as the moment of inertia I. This one is also the new term. The moment of inertia, the unit of the moment of inertia is kg meter square. After that, we call the momentum, linear momentum. It is recorded taken as the T. The momentum is taken as mass into velocity. In the case of the rotational motion, there is termed the angular momentum L. Angular momentum L. Here there is mass into velocity. For the mass, we take I, and for the V, we take omega. That is the angular momentum is taken as I omega. This angular momentum can also be called as the moment of momentum. This torque is called as the moment of a force. This is called as the moment of momentum. The angular momentum L is equal to I omega. Its unit is kg meter square per second. Kg meter square per second. After that, the power is equal to before that the work is equal to force into displacement. Work is equal to force into displacement. The unit of the work is taken as a joule. The work is a scalar quantity. Work is equal to force into displacement. In the case of the rotational motion, the work is taken as equal to here. For the force there is term torque. For the displacement there is term theta. That is torque into theta is called as the work. One more term that is called as the power. Power is equal to work upon time. Work upon time. Power is equal to work upon time. That is taken as the F bar dot V bar. F bar dot V bar. In the case of the rotational motion, the power is equal to for the F. This is the torque T bar dot omega bar. These are the different related quantities for the translational motion and the rotational motion. After that, for the V and for the omega, the relation between the V and omega, V is the linear velocity, omega is the angular velocity. The relation between them, V is equal to R omega. V is equal to R omega. In the vector form, this is written as V bar is equal to omega bar cross R bar. This is the relation between the V and omega. Same is for the acceleration. For the acceleration, A is equal to R alpha. A is equal to R alpha in the vector form. A bar is equal to alpha bar cross R bar. A bar is equal to alpha bar cross R bar. Then the centripetal acceleration. The centripetal acceleration. Centripetal acceleration, that is the acceleration which is along the radius and toward the center. Before that, the period t is equal to 2 pi upon omega. That is the time taken by the particle to complete one oscillation or one revolution. T is equal to 2 pi upon omega. Always use the word capital T for the period. For the time, use the word small t. Period t is equal to 2 pi upon omega. The period T of the second hand is 60 second. That for the minute hand is 60 minute. That for the hour hand is 12 hour. That for the spinning motion of the earth, the period T is equal to 24 hour. From that we can calculate the angular velocity of the second hand, minute hand, hour hand, or that for the earth. Therefore T is equal to 2 pi per omega, that is the period T. Then the frequency n is equal to omega upon 2 pi. Frequency means the number of revolutions completed in 1 second or unit time, or the number of oscillations completed by the particle in unit time or in 1 second, that is called as the frequency. For the frequency, the unit is hertz, that is for the period time, the period T, the unit is second. For the frequency, the unit is hertz. After that, we have taken the omega bar, alpha bar. These are the quantities in the rotational motion. Then the angular velocity and the angular acceleration, their directions are given by the right hand thumb rule. Right hand thumb rule. That is for the direction of the alpha bar and omega bar, or for the angular displacement delta theta bar, omega bar and alpha bar. Their direction is given by the right hand rule. In the case of the translational motion, the direction of the velocity is along the direction of the motion. But in the case of the rotational motion, the direction of the delta theta bar, that is the infinitesimal angular displacement, angular velocity, and the alpha bar are along the axis of rotation, which is given by the right hand rule. For that, we can consider two types of the motion. That is, suppose the anti-clockwise motion. Anti-clockwise motion. Anti-clockwise motion. In the case of the anti-clockwise motion, the direction of the velocity or angular velocity or angular acceleration is directed upward, that is omega bar or alpha bar. In the case of the clockwise motion, the direction of the angular velocity and angular acceleration is directed downward, which is given by the right hand thumb rule. Curve the fingers of the right hand in the direction of the sense of rotation. Then the stretched thumb gives the direction of the vector. That is, in the anti-clockwise motion, we curve the fingers in this direction. The thumb gives the direction of the omega bar or alpha bar. In the case of the clockwise motion, this is the direction of the omega bar, alpha bar, that is called as the right hand rule. Then the uniform circular motion. The second will be the non-uniform circular motion. the uniform circular motion, it is also called as the UCM. Now in the case of the uniform circular motion, the speed of the particle is a constant, that is the linear speed or the angular speed is constant. There is a difference between the speed and the direction. We call the word as speed or the velocity. स्पीड आपण मराठीमध्ये गती म्हणतो, वेलॉसिटीला आपण वेग म्हणतो. Now the difference between them, speed is the scalar quantity and the velocity is the vector quantity. In the case of the uniform circular motion, the speed of the particle is constant and that is called as the uniform circular motion. Whereas in the case of the non-uniform circular motion, the speed of the particle is not constant, that is during the circular motion. If the speed is constant, then it is called as the uniform circular motion. If the speed is not constant, that is called as the non-uniform circular motion. If you observe the motion of the tip of the second hand, minute hand, that one is the uniform circular motion. When we on the fan, initially its speed goes on increasing, that is its speed is not constant, that is called as the non-uniform circular motion. If we stop the fan, its speed goes on decreasing, that is speed is not constant, but after some time the speed attains the constant velocity and that is called as the uniform circular motion. Non-uniform circular motion, the speed is not constant. In this case, for the circular motion, there is a need of the centripetal acceleration. The centripetal acceleration, that is which is along the radius and toward the center. This centripetal acceleration is given as equal to v square upon r, or this is equal to r omega square. V square upon r omega square. This is the centripetal acceleration, that is written as AR. Now in this case the speed is constant, therefore this acceleration, the magnitude of the acceleration is constant. Now in vector form, this acceleration is written as AR bar is equal to minus v square upon r into r0 bar. This is called as the unit radius vector. The radius vector is along the radius but away from the center, therefore there is a negative sign. The centripetal acceleration in this case is given as minus omega square r bar, where r bar is called as the radius vector. That is in the case of the circular uniform circular motion, the centripetal acceleration is constant but it is having the negative sign. In this case, the velocity at a point, that is in the circular motion, suppose this is the circular motion, this is the center, this is the direction of the radius vector, this is the direction of the centripetal acceleration AR bar. Now the velocity at a point, the velocity at a point is given by the tangent drawn at that point. This is the direction of the velocity, that is v bar. The v bar is perpendicular to the radius vector, that is velocity is along the tangent. The magnitude of the velocity is constant but its direction is not constant. It is changing from point to point, that is at this point velocity is along this direction. If the particle is at this point, the velocity is along this direction, that is the v bar. And therefore the direction of the velocity goes on changing, its magnitude is constant, that is the uniform circular motion. We take the acceleration as the rate of change of velocity, but we are having the wrong concept. We know that we consider that whenever there is a change in the magnitude of the velocity, then there is acceleration, but that is wrong. The acceleration is due to the two reasons. One, due to the change in the magnitude of the velocity. Second, due to the change in the direction of the velocity. In the in the circular motion, the direction of the velocity changing from point to point, but its magnitude is constant, therefore it is having the acceleration. Remember that without acceleration, the circular motion will not take place. For every circular motion, there is a need of the centripetal acceleration, that is centripetal force. Centripetal force means mass into the acceleration. Without the centripetal force of centripetal acceleration, the circular motion is not possible. In the case of the motion of the stone in the sling, there is a centripetal force, that is the tension imparted by our hand on the string. The electron revolves around the nucleus. The centripetal force is given by the attraction, electrostatic force of attraction between the positively charged nucleus and negatively charged electron, that is for the uniform circular motion, that is the motion of the particle in the circular motion with constant speed. In the non-uniform circular motion, the speed is not constant. The example of the non-uniform circular motion, that is whenever we start the fan, initially its speed goes on increasing, that is called as the non-uniform circular motion. Again, the non-uniform circular motion, that is the vertical circular motion. Suppose the stone is tied to a string. If the string is revolved in this direction, in the vertical plane, in that plane, that is called as the non-uniform circular motion, that we are going to consider in this chapter. That is the vertical circular motion is the non-uniform circular motion. At the bottom the velocity is large, at the top the velocity is small, that is the velocity does not remain constant in the vertical circular motion, and that is called as the non-uniform circular motion. That is up to this point, up to this part, these formulas are important, that is the centripetal acceleration and the centripetal force. Afterwards, we are going to consider the distinguishing point between the centripetal force and the centrifugal force. The centripetal force, that is centripetal force. The second is the centrifugal force. This is taken as CFF. This is taken as CFF. Now, the centripetal force or the centrifugal force, the first force is along the radius and towards the center, which is in the circular motion. That is, the centripetal force is responsible for the circular motion. Due to the centripetal force, we get the circular motion, that is, it is responsible for the circular motion. Whereas the centrifugal force, which is along the radius but away from the center. We could take the example of the merry-go-round. In the case of the merry-go-round, we observe the outward pull on the student or on us, that is called as the centrifugal force. Both the forces are having the same magnitude. The centrifugal force balances the body. The centripetal force provides the circular motion, force required for the circular motion, both are having the same magnitude but having the opposite directions, and therefore the centripetal force is equal to mv square upon r, or this is equal to mr omega square, whereas in the vector form it is written as minus mv square upon r into r0 bar, where r0 bar is called as the unit radius vector. Now this is equal to minus m omega square r bar, where r bar is called as the radius vector, whereas the centrifugal force is having the same magnitude, only having the opposite direction. Centrifugal force is equal to mv square upon r is equal to mr omega square. In vector form this is written as mv square upon r into r0 bar, or this is equal to m omega square r bar. That is, these two forces are of the same magnitude but opposite directions. The centripetal force is responsible for the circular motion, where the centrifugal force balances the body that is having the same magnitude as the centripetal force. Examples of the centripetal force is the motion of the, we have seen the motion of the electron round the nucleus, the motion of the stone in the sling, where the centripetal force is supplied by the tension imparted in the string. In the case of the electron, the electrostatic force of attraction between the positive and negative charges at the curve, the vehicle performs the circular motion, where the centripetal force is supplied by the force of friction between the rubber tires and the road surface. The centrifugal force we observe in the case of the merry-go-round. In the case of the washing machine, the cloths are dried in the dryer, that is due to the centrifugal force. These are the examples of the centripetal force and the centrifugal force. In the case of the circular motion, we have seen about the centripetal acceleration. Centripetal acceleration is along the radius and toward the center. There is again the tangential acceleration. Tangential acceleration. This is the direction of the AR bar, that is the radial acceleration. This is the direction of the velocity, that is V bar. Now this is the direction of the tangential acceleration, that is 80 bar. If there is the tangential acceleration, then the magnitude of the velocity goes on changing, that is, it does not remain the uniform circular motion. In the uniform circular motion, the 80 bar is equal to 0, but in the case of the non-uniform circular motion, it is having the AR bar and 80 bar, that is the velocity is along the tangent, acceleration is along the tangent, and acceleration is along the radius and toward the center. The resultant acceleration in the case of the non-uniform circular motion is given as A is equal to square root of AR square plus AT square. This is the resultant acceleration for the non-uniform circular motion. For the uniform circular motion, AT is equal to 0. In the case of the circular motion, the work done is equal to 0. Work done is equal to 0 because the force is in this direction. Force is in this direction. The displacement is in this direction. That is, the angle between the force and the displacement is 90 degree. we take the work as the product of F bar dot S bar. W is equal to F bar dot S bar. This is the real formula of the work. We always use W is equal to Fs, but actually the exact formula of the work is F bar dot S bar. That is equal to Fs cos theta. Fs cos theta. In the case of the circular motion, the angle between the displacement is in this direction. Take the example of the sling गोखर म्हणतो आपण. In the case of the sling, when the stone is released, it moves along the tangent. The force is in this direction. The angle between them is 90 degrees. Cos 90 is equal to 0, and therefore the work done is equal to 0. Therefore, remember this thing, that is in the circular motion, the work done is equal to 0 because the angle between them is equal to 90 degree. Cos 90 is equal to 0. Thus, up to this point, we have seen many terms that is regarding the circular motion, that is in the chapter of the rotational motion. Rotational motion means the motion of the particle